This one you're supposed to recognize as a difference of squares. If you need to, rewrite it like this. So this thing is called what we call a difference of squares. So think of it as like a squared minus b squared is equal to a minus b times a plus b. Is that ringing a bell at all? Okay, now let's actually do it. So sine fourth x minus cosine fourth x would mean it's sine squared x squared minus cosine squared x squared, right? So there's your difference of squares. So then you can rewrite that as sine squared x minus cosine squared x times sine squared x plus cosine squared x. And this is the Pythagorean identity that equals 1. So therefore you would have sine squared x minus cosine, I probably wouldn't write out this step, I'm just making sure we get it, times 1, which basically just means it's...
For all ninth graders, you need to hustle out front, get on the bus, back to school. Thank you once again for your attendance.
Now technically, couldn't you actually do a difference of squares on that again? Yes, but would that accomplish anything in really making it look more simple? No. So that's why they leave it at that point. Okay, let's go back to 15, unless you want to look at that a little longer. Do we get that? Okay. Number 15, we can use what we just barely did, Cody, with this one. Remember what we just did in that other example where we broke it into two fractions? Yes. I recommend that. So 1 over cosecant theta plus cosine theta tangent theta cosecant theta over cosecant theta. So then I can, now that I've kind of separated those out, I can cancel that and that. And what is 1 over cosecant theta? 1 over cosecant is sine, correct? So I have sine plus cosine times tangent, but let's go ahead and change tangent. What's tangent? Sine over cosine. So then that cancels. So then we have sine alpha plus sine alpha is 2 sine alpha. Sorry, I kind of went fast on that one. Okay, Cody, ask. Go ahead, ask.
What I did is I immediately transferred everything to the sine and cosine since that's one of the first things we learned.
Okay, that makes sense.
Look at a problem and then know which step is the best.
Practice? Okay.
I will practice.
But that does not mean that the way you did it is bad.
I ended up like 3 times. There's multiple ways to do it. Some ways you just have to.
Yeah.
And some ways.
Yeah. So there, so if you take that and change everything to sines and cosines, you would have started with this instead, maybe? Okay. So then you would have 1 plus, did you realize that those would cancel? So that's 1 plus 1 over 1 over sine alpha. So that's 2 over 1 over sine alpha. And then you can copy dot flip. So 2 times sine alpha over 1, which would be 2 sine alpha. So it's just looking for things to make it easier. Okay, that's good. I mean, I'm trying to go slow with this because I know that this chapter is a bear for a lot of students. So I'm really trying to get some clarification with the, you know, this easy stuff first. I shouldn't say easy because...
If I put the cosine over 1, then I probably would realize which is cancel.
Oh, yeah, that's helpful.
Because I never even put the 1
Yeah, that really helps to visualize it better to do that.